Hello everyone, welcome back to another episode of Mr. Walker's Chemistry. And today we're going to be talking about electrons. Alright, this is all under the theme that these last few videos have been of the modern atomic theory. What do we know about atoms? What do we believe to be true? And how do we use the information that we know? Okay, so I've kind of started off with this screen every time just to remind you guys of what's in an atom, where they're located, and how we can use some of that information. So a little bit of review here. Okay, so the atom makes up everything. It is matter. That's what we study in chemistry. So we're going to spend a lot of time on the atom in chemistry. Makes sense, I hope. All right. In the atom, you have protons and neutrons, which, as you can see from this diagram, are located in the middle. We call that the nucleus. Okay, this is the nucleus. And around it are the electrons. All right. Because this is carbon, it must have 6 protons. Okay, carbon is number 6 on the periodic table, so it has 6 protons. It also has 6 neutrons. So as a review, okay, 6 protons plus 6 neutrons, that will equal a mass of 12 atomic mass units for this particular atom. Okay. Now, I hope you're starting to ask, we haven't talked about electrons, I hope you're starting to ask, well, electrons, don't they have to weigh something? You know, why is it always 6 plus 6 equals 12? Don't they weigh anything? In truth, yes, electrons do have a mass. They do weigh something, but we tend to ignore that. And we're going to learn about that today in this video. Okay? So just as before, by the end of this video, you should be able to tell me the definition of an electron. Okay, what's its charge? Where's it located? How much does it weigh? And how do we use these things in chemistry? What are electrons useful for? And to be quite honest, in this video, we're only going to go into a tiny, tiny bit of what electrons are actually useful for. And throughout this course of chemistry, throughout the entire year, electrons are going to play a very big role because they do most of the work in chemistry. Okay, so what is an electron? All right, we've got our atom here. Electrons would be these little yellow balls. All right, they go around the outside of the nucleus. They don't necessarily follow these perfect little rings like we learned about in the history of the atom. They are more in what we call orbitals. All right, and we're going to spend more time on that concept in the future. Okay, they are subatomic. They are smaller than an atom. They orbit the nucleus. Okay, don't get these confused. Protons, neutrons in the nucleus. Electrons are outside the nucleus. All right, this is very important here. So let me box this in here. Okay, electrons orbit the nucleus. They go around it like planets around the sun. Right? Electrons do have a negative charge to them. So oftentimes you'll see people draw the electron symbol like this. They'll do an E with a minus sign as the abbreviation for electron. All right? So electrons have a negative charge. So protons in the middle have a positive charge. Electrons on the outside have a negative charge. These guys, the positives and negatives, are actually attracted to each other, and they are trying to pull each other in. It's a constant war. This is what holds atoms together. All right. So about their mass. Well, they are very tiny. Okay, remember that protons and neutrons are tiny in and of themselves, with a mass of 1.6 times 10 to the negative 24th. Well, electrons are even smaller. They are approximately 9 times 10 to the negative 28th. So we're adding 4 more zeros in front of this number. We're having 27 zeros in front of this whole number that you see. That is a very small thing. So this diagram is actually fairly representative, where they're showing electrons smaller than protons and neutrons. This is not an exact scale. In fact, if you could see a proton, you probably wouldn't even be able to see an electron. But nevertheless, they are, there, where the electron is smaller. So because they are so small, all right, before, with protons and neutrons, they were small, but they were not the smallest, so scientists still gave them a number. Well, in this, with electrons, scientists just said, this is such a tiny, tiny, tiny number, it's insignificant. It has no effect on the chemistry that we're doing. So let's just pretend that it is 0. And so we will follow that assumption for this class. All right. So for this class, we will assume that electrons weigh 0. They weigh nothing. They have no mass. So how do we use electrons? What are they really for? All right. Protons are used to identify the element. Neutrons are used to identify the mass of the element. And electrons are used to identify the charge of an element. What do I mean by the charge? Well, I mean, is it positive charge? Is it a negative charge? Or is it a 0 charge? So let's use this diagram as an example before we go into more practice. Okay, we have 2 protons here. Okay, so we have a proton here and a proton there, and then we have electrons out here. Okay, so we've got 2 electrons and 2 protons. So the protons there are 2 of, the electrons there are 2 of. We know that protons have a +2 charge because there are 2 of them. So this is +1, +1. So protons overall equal a +2. All right. Now let's look at the electrons. Each electron has a -1 charge. -1, -1. So now the electrons equal -2. Well, a slide ago I said that the protons and neutrons are always, attracting each other and trying to fight. It's like a giant tug of war among these subatomic particles. So they cancel each other out. The charges are exactly opposite of each other. All right. So this is like you and a clone, you and your evil twin or something playing tug of war. You're exactly equal, so the flag never moves. And that's what's going on here, where there's this balance. So this +1 cancels this -1, and this +1 cancels that -1. So overall, the entire atom, so I'm going to box in the atom, has a charge of 0. It is neutral. Okay, and you can see the math here. The opposites cancel, so 2 plus -2 equals 0. For those of you out there who are very math-oriented and like to see things in formulas, this is simple. Okay, it's number of protons plus the, should be minus the number of electrons, and that will equal your charge. All right. So protons minus electrons equals charge. Simple enough. Okay. So if given the charge and number of electrons, you can find number of protons. Given protons and charge, you can find electrons, etc. As long as you have 2 out of 3, you can always find the third easily. So let's think about this, and let's do a practice example. If I tell you I have an atom of lithium, which is Li, you will find it on the periodic table, and you will find that it has an atomic number of 3. So that tells us that it has 3 protons. Okay, so we're going to take this, we're going to take that number, okay, this number right here, pull it down here, we're going to say that we have 3 protons. Okay, so now I'm going to give you charge. Okay, so it has an overall +1 charge. How many electrons does it have? All right, so let's set up our formula. 3 protons minus an unknown number of electrons equals a +1, a +1 charge. Easy enough to solve. This is basic arithmetic. So 3 minus x equals 1. So 3 minus 2 equals 1. So we have 2 electrons. Not too hard. All right. So let's go back and look at the periodic table and do some more practice. As always, I'll do one for you, and then you do the rest. Okay. So here's our periodic table, same one we've been using in each video. I like this one because it's very clear. It gives you all the information you need. So, first thing, identify the charge of an element with 15 protons and 16 electrons. All right, 15 protons, 16 electrons. Well, it has 15 protons. We know that that is the same as our atomic number from the protons video. So we can identify this as phosphorus. However, it's asking us to identify the charge. So let's use our formula. Always, whenever you're doing something, it's good to write the formula at the top so that you don't forget it. So protons minus electrons equals the charge. I'm just going to abbreviate this time, CH, okay? So if I have 15 protons minus 16 electrons, I get a charge of -1. And that is, in fact, correct. Because remember, think about this conceptually as well. Imagine these things floating around in your head. Electrons are a -1, so think of this like 16 negatives. And then protons are positive, so I have 15 positives. Well, one positive will cancel one negative. So in the end, I can cancel 15 of these, but I'm left with one negative left over. So I have a -1. Okay, that's not too hard. How about this one here? Let's do this one, and then I'm going to leave the other two for you to do. All right, the last one here is a review question because it's asking you about mass as well. So, how many electrons are in oxygen with a -2 charge? Well, important to note that we have oxygen. Okay, so we're going to find oxygen on the periodic table. It's right there. We're going to note that it has 8 protons. All right, so let's write that down. We have 8 protons. We're asked how many electrons, so we know that that's probably going to be our x. So 8 minus x will equal a -2 charge. So 8 minus x equals -2. I think you can solve that, so go ahead and do so. See if you know what x is. Right? And continue along with these. Okay, what will be the charge if I have 20 positives and 18 negatives? Figure that one out, and figure out the mass if I have 15 protons, 15 neutrons, and 15 electrons. Remember how much that protons, neutrons, and electrons weigh. Okay, that will be important, and how you can find mass. So let's review. What's an electron? An electron, quite simply, is a subatomic particle. It is located outside the nucleus. It has a charge of -1. It does not weigh anything, and it is used to identify the charge of an overall of an atom. Okay. So please make sure you understand these and can answer these questions without me. Okay, maybe mute it and come back to this in a day or two, see if you can still answer these. Look back over the information, and as always, you can ask me questions in class. Hope you learned something, and I'll see you next time.